Good morning, everyone. I hate to interrupt discussions because it's great to see all of you talking away and being happy and being here in the room with us. But nevertheless, I'd like to open the Symposium 2024 here in beautiful Lucerne. Welcome to all of you. Welcome to the 2024 Symposium. Exactly 1 year ago, we met in Paris. Many of you were there, and it's great to see so many of you back. But exactly 61 years ago, the DGs of the European Civil Aviation Conference of the ECAC met here in Lucerne. Understandably, they always pick nice places to meet. At that time, there were 19 DGs, and they founded EUROCAE. So it's actually great for us to be back here at the place of our birth, the place of our creation, and still celebrating our 60th anniversary. And it's great to celebrate it with so many of you. In the meantime, back then EUROCAE had 23 founding members. In the meantime, we have 20 times that many, so close to 500. It's great to have 2 full days of discussions, of networking. We took the feedback from last year. We made the networking breaks a little bit longer so that we can all have time to chat away and network. First of all, I'd like to thank also, I can make this work. Thank also our sponsors, Skyguide as our platinum sponsor, and not only for the sponsorship, but also for the great support in the organization of the event, so making this here possible in Lucerne. Our gold sponsors, Airbus, INDRA, and Thales, silver and Collins, bronze, and also for the lanyards to Frequentis, and also thanks to Honeywell and ANSEN for bronze sponsorships, and our partner, the European Commission, is always on board as well. We have a Slido code that is available. It will be the same code for all of the sessions, so make sure you flash it so that you can ask questions to the panelists. And in case you haven't found out yet, there's a Wi-Fi that you can use. To register, you just have to put your phone number in. It works. Most of the cases. It's a little bit slow, but the codes come through. So please register if you haven't done so, and let us know if you have any issues with it. So without further ado, I'd like to turn it over to our president, Guillaume Roger, for some introductory words.
So welcome everyone. Thank you for attending the 2024 EUROCAE Symposium. I am Guillaume Roger, and as EUROCAE President, it's my privilege to address you a few words at the beginning of this meeting. Rest assured, I won't take long, as we have a very busy day today. We are going to discuss some key topics really important for the future of the aviation industry. I'm sure this is going to lead to very interesting discussion, and I invite all of you to liaise with the panelists and continue this discussion during the breaks. As Anna mentioned, I would like to thank once again our sponsors, and I would like particularly to thank Skyguide and FOCA for hosting us here in Switzerland. Switzerland is in the real heart of Europe and has always been a very important partner for our programs and activities. It's definitely an innovative country, involved a lot in EUROCAE today, with participating in several groups, sharing some others, and with Thomas participating in the council. And from the very beginning, as Anna recalled, it all started here some 61 years ago in Lucerne. So thank you very much to all of you. Enjoy the symposium.
And as the first speaker and representative of our host country, I would like to invite Francine Zimmermann, who is the Director for Aviation Policy and Strategy Division at the Federal Office of Civil Aviation. Francine, bienvenue.
Good morning, everyone, also from my side, and thank you very much for the invitation. It's a real pleasure to be here in the beautiful city of Lucerne, at the birthplace of EUROCAE, like Anna and Guillaume just mentioned before. 1963 is a very important year, but let's go back later to that year. So Anna mentioned my division is Aviation Strategy and Policy, so it's all the topic that's not related to safety. So my division activities has a wide spectrum. It goes from approving plans to build a new hangar, to negotiating air service agreements or implementing initiatives to promote the use of sustainable aviation fuel. But let's go one level up, FOCA, the Federal Office of Civil Aviation. FOCA is responsible for regulation, oversight, and certification of all civil aviation activities in Switzerland. And first and foremost, its mandate comprises the protection of public interest, such as safety, security, and environmental protection. So I believe we can say that we have a shared mission, FOCA and EUROCAE. Technical standards set by entities such as EUROCAE are key for the aviation industry. It's really by working together that we can create a framework for create innovation and also push our industry forward. In the very developing rapidly area of drones, standards have really shown how they have remarkable impact. Back in 2020, EUROCAE published a standards in support of an EASA regulation dedicated to creating US geographical zones. And these so-called geozones promote orderly and responsible drone operation by providing pilots with clear information about where and how to fly. So we can say that thanks to EUROCAE's work, drone operator and manufacturer can access to the same information on geozones everywhere in Europe. So a drone operator in Switzerland has access to the same data as one in Spain, making flight easier to plan and safer to operate across border. So I think we can say that it is the first real publicly available US data in Europe. And this is a very nice example to show how a standard goes from ideas to practice. Earlier this year, the same standard was updated to integrate some requirements coming from the U-Space regulatory package, another very important European regulation supporting to enable complex drone operation. And here again, these two standards, the one that was updated, show EUROCAE ability to have an impact and to work together with EASA and the member states to amend the regulation. And I think this is really crucial for the community, not only from a technical point of view, but also just from the symbolically, that entities like EUROCAE work with EASA and its member states to amend the regulatory change. And here I think we can say that EUROCAE can be particularly proud to the fact that it was able to reach consensus quite quickly, point by point and from different perspectives to update that standard. So this is really, really key, and I would like to welcome, to congratulate EUROCAE for this. Of course, this was also possible thanks to the whole community wanting to move forward from a cutting-edge industry to an exceptional lead. And I would say, make no mistake, this standard that I just mentioned have an impact because of the high quality and because of their practicability in practice, the usability in practice. So I am really confident that EUROCAE will continue on the standardization in the drone space to have impactful standards and showcasing this attribute and thus make an impact in Europe and hopefully far beyond. Emerging technologies such as drones are only one of the examples where EUROCAE has a critical role. And there are many, many other domains. I mean, I can mention maybe avionics, satellite-based navigation, aircraft performance monitoring, aircraft noise, aircraft emission, and so on. But enough talk about technical standards. Let's go back to 1963. I told you at the beginning we will come back to that important year. So what else happened in 1963? And please don't ask ChatGPT or Google. Just let me know if you have something in mind, what happened back then. Anyone has an idea? No? I'm a bit disappointed. I thought that you will say that the Boeing 727 had its first flight, or maybe that that year saw Joseph Walker reach an altitude of 107,960 meters with a rocket plane. Quite nice, right? but those are not what I had in mind, although they are pointing to the direction of daring and dreaming big. In 1963, Martin Luther King gave his famous speech, "I Have a Dream." So I was wondering, is that a coincidence? Or may we have a dream as well for the civil aviation, crewed and uncrewed aviation? In any case, I have a dream. And my dream would be the following: a sustainable aviation benefiting from cheap access to airspace with a fully digitalized air traffic management and with all the airspace users flying conspicuously. I would love to hear about your vision of the future. Before to pass the ball to Klaus Meyer from Skyguide to listen to his vision of the digitalization of aviation, I would like to come back and to thank you for the good work. Your contribution is key for the aviation industry and to fulfill my dream, of course. So please keep up the good work. I wish you all a good symposium. Thank you.
Thank you so much for these inspiring words. It's always great to have a dream, and indeed, as Guillaume also mentioned, here in Switzerland, we see lots of great innovation happening, and I'm very pleased to welcome Klaus Meyer, the CTO of Skyguide, to the stage and to address a couple of words to the audience. Welcome, Klaus.
Thank you, Anna. Thank you, Guillaume, for the opportunity to be here and give also the opening remarks to this symposium. I'm also here as the representative of Skyguide, as the Chief Technology Officer. For me, it is always an honor to be able to talk about the visions or the ideas that we have and share them with you. And I think it was really fitting of Francine to go back to 1963 and bring Martin Luther King into the topic and say, hey, I have a dream. About the same time, another guy said, how can we get to the moon by the end of the decade? And this also seemed at that time completely impossible and absurd. And at the end, they made it. And despite all challenges that they were facing on that program, in particular, a year before they landed the lunar module on the moon, everybody thought the space program was dead. And believe me, I've been driving innovation in aviation now for quite some time, and I'm also going through periods where the going gets tough and where it's not easy. I mean, where you need a lot of ice in your stomach to stand it and believe in the dream that you have, and that the dream comes true, and continue on the path. And fight and do the right thing. And first of all, learn also from the mistakes. I'd like to take you quickly through a tour of where we're going at Skyguide and what we want to do. So I would say it's forward, no? Okay, good. Francine talked already about digitalization, and I deliberately picked the topic digitalization because I strongly believe that technology is here now that puts pressure on the way of how we're doing business in aviation. You see it on the one hand on the aircraft side, but also in the whole environment around an aircraft flying through an airspace. It's the technology that drives that change, and I want to go a little bit more in detail now as we move on. As a first step, I want to introduce you to digitalization and the way of how we use digitalization in Skyguide and how we try to also communicate it, because we see a lot of times confusion about what digitalization really means. And I use this example that you have to take 4 steps in order to be successful with digitalization. The first step is the obvious one. You move from analog to digital. You move from analog signals, and here I'm speaking as an engineer, and please bear with me, but analog is a very sexy thing. Signal processing is something very sexy, but it has been replaced by cutting it into small pieces, putting into packages, and distributing it. It's a brutal way of doing it, but that's what's happening. And all across, all around us, this is happening. Everything is put into little pieces, digital packages that are then sent around. In order to take the next step out of this digitalization, you need to have connectivity. You need to have a network that allows those packages to be sent from one place to the other. Whether this happens within a box of a computer, even there it's happening already, or this happens within a local area network or wide area network across basically the oceans. It's done the same way. We provide connectivity. What does that mean? That means suddenly data is available all across the world. You have an IP address and you have access to this information. Think back in aviation, for example, a radio. The classic radios we're still using today to talk to an aircraft is analog. So we basically have a point-to-point connection from the radio to the center, and we talk to an aircraft. So we need to have a very local connection to this radio. If I have an IP-based radio and it's connected on a network, on an internet, I can access any kind of radio all over the world. If you push it further, if you look at what happens with Flight Radar 24, what is the power of Flight Radar 24? It's the fact that I have a signal that I can receive all over the world, and someone can buy for $20 a receiver and connect it to the internet, and now you can watch a C-130 landing on McMurdo in the Antarctica. Again, we don't do air traffic management that way. That's not yet certified and not probably safe, but it just shows the power of connectivity and digitalization. You suddenly have access to information, location independently. Now, if you can do that, if you can send information around in a network, you can also aggregate data. You can collect data. And the more data we have, if you have aggregated data, I can put algorithms behind this data. I can put suddenly intelligence into it to assess data, good data, bad data, and the content of this information that this data is carrying. And that opens up the whole topic of artificial intelligence, or let's call it first some more intelligence in the system. Could be artificial intelligence, but you create intelligent system. Without digitalization, you can't have artificial intelligence. Without connectivity, there is no artificial intelligence. And without connectivity or aggregation, you can't put intelligence in the system. So if you go through these four processes, then you suddenly start to question, so how does that have an impact on the way of how we're doing business? How can this have an impact on the way of how we fly an aircraft, how we manage an airspace? Think about how we manage an airspace today. And I think these are the challenges that we are facing if we talk about digitalization. And digitalization is here, there's no question. And we need to learn now how to use it to the benefit of aviation in the future. So the situation that we encounter is that airspace is still managed locally. We still have a very strong concept that the whole management of an airspace is done by having equipment on the ground, and this equipment reaches an aircraft. It started with a radio that had a certain range with which I could speak to an aircraft, early 20s of last century. Interestingly, we very quickly moved from amplitude modulation to frequency modulations. In other areas in aviation, we stayed with amplitude modulation, like in the 1920s of the last century. But that's the way of how we were talking to an aircraft. Later on, we learned to use electromagnetic means to help an aircraft land at an airport, even if the weather was not so good. Kind of early ILSs. Again, very local. There was a certain range, 10, 20 miles, but you could send a beacon such that an aircraft could find the runway and land safely on the runway. Then during the Second World War, radar came up, and we learned to use radars around airports, local. And then after an accident over the Grand Canyon in the late 50s, we decided to expand this radar coverage along airways. such that we can follow an aircraft as they fly over the continent. It was always location-based, was always local, because it was depending on a technology that had only a certain range. That's what we still do today too. We manage airspace locally. We have in Switzerland an area control center in Geneva, where the system is in the basement of the area control center. We have star-shaped connections to the sensors, and we manage the airspace above Geneva. And that airspace we cut even into smaller local pieces, which we call sectors. And we manage that sector by a controller talking to the pilot via an amplitude modulated VHF signal and tell them faster, slower, descent, climb. I'm exaggerating a little bit, but this is the way how we're doing it, and we have been doing that for the last 60 to 70 years. That's the challenge, and now again applying technology, what does that mean for us? This is a picture, I'm sorry it's blurry, but I think it should be blurry. It's a forecast of Eurocontrol on traffic in 2035. And they forecast that 68% of the area control centers in Europe will not be able to digest that capacity anymore. Now, sustainability is a topic, flight shame is around, but, airspace will be needed. We will continue to fly, whether this is manned or unmanned. So airspace is a limited resource that we have, and we need to manage that correctly. That's the challenge we are facing. And the question is, can we make even more sectors, smaller sectors, put more controllers on the sectors in order to digest this kind of traffic? And the answer is pretty clearly, no, this will not be feasible anymore, and we need a paradigm shift. I'm still defending our controllers, doing a tremendous job every day in making sure that travel and flight through the airspace is safe and as efficient as possible. But I picked this picture to show that can be also an overload on a human being, looking at the challenges that we are facing in a modern airspace. And it's a normal environment. You're sure it's the HMI in front of the controller that gives him the information. There's a lot of additional information. And the question here again is, how does digitalization change the business model on the operating model, let's put it operating model, of an air traffic management in the future in 10, 15, 20 years? So, good. I picked that picture, I love that picture because there's an aircraft flying another aircraft in the other direction. It's en route, it's high up, they move with 500 miles per hour, in opposite directions. And to think about en route management, it's done by a human being still. And they approach each other with such high speed. Is that the smartest way of doing it if we look at technologies that would be available? And the question that I'm having here is, how can we have systems helping us to manage that more efficiently? If you look at the en route piece, it's a network in Europe. We also have a network manager. The network manager is doing what he, or shall I say she, can, as much as possible to optimize it. But it's very political, it's very difficult. I think we have reached the least common denominator what we can do centrally in Europe. Because we still focus on our sectors to optimize the flow, instead of looking at the full network. I always say we have a very expansive, but also very sophisticated railway system here in Switzerland. I don't know whether you had a chance to take the train. Around Zurich, we have a clock rate of 5 minutes, trains going into a station and out again. This is managed highly efficiently, and here too, support for our railway systems. But I sometimes compare it, would we be able to have such a working network if we would not would manage the network, but would manage the train traffic in Switzerland from the stations, like what we did in the 50s? Is the station free? Can a train go in? It's not free, stop or slow down and then drive out. We don't do that way. We look at the full network and we optimize basically the flow through the network by a system. And this is, for me, the question whether we would move in the same direction for air traffic management too. You know, the answer that I got in the beginning when I joined the industry was, well, it's non-deterministic, so we can't do it. It's true, there are factors that influence that, like weather, thunderstorms, yeah. Also delays coming from the airports. They have a ripple effect into the network, the en route network. But that can be simulated too. Maybe we use real-time simulation for that, flow management. And we are quite good in that. We are quite good in forecasting even weather. Yes, we have sometimes fog. Fog is still a very difficult one on airports. But in general, you know, there are enough means around to do probably 80–90% on a network, and we need to move in that direction. To do that, we need to connect area control centers. We have 68 area control centers in Europe, but they're basically not connected. They still operate very much vertically integrated locally. Now, we do share some information across Europe, but limited. Imagine if we would have a flow of the information in a European network and a system is managing the en route airspace. We could help the controllers to unload the conscious load that they have, managing 2 aircrafts, flying with 500 miles per hour towards each other. So this is one of the visions that we have and dreams we have to say, let's use the systems, but be ready for digitalization, use connectivity, aggregate data, and help to make these kind of decisions. And, I came from the airline industry to the air traffic management, and I always said the reason why Europe is not working is air traffic management. So I'm proud to be in air traffic management and work in this area. But if you look at it, 300 feet above ground, Europe has ended. So let's give that some push, and it needs the vision and the courage to go in that direction. Now, that could be just a dream because we like to have dreams. But Martin Luther King really understood what was hitting the American society in the 60s. There was a paradigm shift in the society too, and that's why it was also the right time to raise that point. I strongly believe it's the right time in aviation too to take that step forward, and I want to use 2 examples as disruptors that are hitting our industry, which we cannot neglect. And the first one is, for me, space-based functions. It started with GPS in the 90s, late 90s, when the US government decided to open it up also for civil use. And we had basically navigation means shifting from terrestric VORs to, let's say, to GPS. And this example here is an Iridium satellite of Arion having this little white box on top, a payload, an ADS-B receiver payload. These are 66 low-flying satellites. They provide now surveillance coverage globally. They are mainly used for oceanic tracking now. Suddenly we can track aircraft flying the North Atlantic route, or the Iceland-Scotland gap is now doing tactical air traffic management because suddenly we have surveillance information in this area. But what I want to use this as an example for is for moving away from location-dependent services to location-independent services, because now I have a surveillance mean available globally. Arion runs this setup with a 2-shift operation with 3 people out of Virginia in the US. It's incredibly powerful. They're certified now as an ANSP. They don't want to be an ANSP. They know politically they shouldn't do it. But think back how ANSPs were created before, because we had the means of talking to aircrafts, to helping them to navigate, and to find out where they are. With these kind of setups, we have it suddenly available as a global service. So how do we integrate that in managing the airspace in the future? So for a very strong push coming from such a technology. And the second one, and with that I would close the loop to what Francine said. It's the unmanned aviation. And I was always asking that provocative question, how the heck do I talk to them? As an air traffic controller. Hey Siri, descend by 50 feet. Yes, Klaus. Are you sure? I think we got very early involved in the whole drone environment because we felt like there's big business in it yet. There might be. But we got involved because we wanted to learn as early as possible what that means for manned aviation, for how to manage an airspace. And I also want to underline the close collaboration that we had here in Switzerland between the regulator with a clear vision of what role and what we want to do with drones and us as an operator was very beneficial. I do believe we could achieve a lot in this period, and Francine was at that time also responsible for the drone team, but could really make big steps forward, understand what is possible, also not jumping into big conclusions and decisions of creating companies and making a lot of money, but understanding how to integrate unmanned aviation that operates differently into our airspace. First, uncontrolled, but Switzerland, we are so small, we can't segregate drone unmanned aviation from manned aviation. For us, it was always very clear from the very beginning, non-segregation needs to be cohabitation. We need to live together with manned aviation. And I think we did here a great job, and I think we can continue to build on that. We strongly believe that they bring new ideas in. Not just new ideas, it's not a safety approach for all those who are in regulation. They are having still a risk approach. It's refreshing to have the risk approach. We must not forget the safety piece, because aviation is all about safety. But to have a different perspective on how to solve some problems from a purely risk perspective is refreshing and exciting, and I strongly believe that will give a good stimulus into this business in order to make the right decisions forward. And one other thing that we must not neglect when we talk about unmanned aviation, the power behind those initiatives, when you look at those companies which are behind those companies, drone companies, are very powerful, very big. Yeah. There are different players suddenly pushing into this industry, and we must take that very seriously too. And again, there is no question about what technology they're using. They're using modern IT, really an IT that is driving it. Yes, they don't have yet the safety. They haven't taken that step yet. That's why they need us, and we should help them, and we should learn from them what that means for us. And I strongly believe this is the second big disruptor that will keep pushing us forward. And with that, I would close my opening speech with a quote from Saint-Exupéry. And for me, that goes also towards the standard organizations. You know, you don't need to be the innovators. You don't need to have the vision. But what I would expect from you is help us to enable that vision that we have. Help us to be successful with the right standards, to have that dream and reach also the objective of that dream. And with that, thank you very much. And thank you, Anna, for having me, and Guillaume.
Thank you so much, Klaus, for these very inspiring words and this call out to the standards organizations to help make the future possible. And we'll hear about a lot of the topics that have been mentioned in these keynote speeches in these next 2 days. We have a lot of sessions prepared, and I'll turn it over to the very first session, which will be looking at future connectivity, and Mark will introduce it. Thanks, Mark.
Thank you. I'm Mark Watson. I'm one of the technical program managers of the EUROCAE Secretariat team. It's my pleasure to introduce the first panel towards future connectivity. So in October 2023, hundreds of people from around the world joined the joint EUROCAE RTCA summit on future connectivity. So this summit brought together the leading experts and stakeholders from the aviation industry for discussions on the pivotal topic of data link communication in aviation. So the joint EUROCAE summit, joint EUROCAE RTCA summit was a strategic platform for industry players to address the challenges, advancements, opportunities presented by data link technology in modern aviation. So the EUROCAE data link working groups are all joint with RTCA, and I'm very happy to be one of the TPMs that supports these groups. Today we've got the privilege of hearing from a panel of experts who are working on future application, network and physical data links. So the panel is being moderated by Carol Hugel from RTCA. She's the president and CEO of RTCA. Carol has a prominent 30-year career in global aviation industry. She has served aircraft and airport operators as well as air navigation service providers with a concentration on air traffic management. So thank you, Carol, for leading the discussion, and all the panel can come up. And another point is that there are the opportunity for questions at the end of the panel, and you can connect to Slido using this QR code, and the QR code is also available in the program, which is in one of your bags. So thank you, Carol.
Thank you, Mark.
Is it on? Can you hear me? Okay. Good morning, everyone. Thank you, Mark, for that very kind introduction. I am really honored to be here today serving as the leader of RTCA and working very, very closely with EUROCAE. A long history, a long legacy, and a whole lot more to come. So we have a very short amount of time here with you today to start to touch on the future connectivity in our beloved aviation industry. So we're really going to be pulling the thread on the topic that you've already heard this morning, which is what does the future look like in aviation? And we're going to focus on this. You can't hear me? Okay. Should I start over? Okay, let's start over. I apologize. Okay, so again, I'm really thrilled to be here representing a really distinguished team at RTCA and really continuing the legacy that we have really shared and enjoyed with EUROCAE. So we have a really short amount of time here today, and we're going to be continuing the theme of innovation in aviation, which sometimes seems like an oxymoron to those who are newer to our business. So we have a really esteemed panel of experts here. So we're going to have each person introduce themselves very briefly. And then we thought we would start with a couple of graphics. We actually have an excellent artist amongst us, and that is Radek from Honeywell. And his daughter, he does like to give her credit here for these graphics. So what we want to do is kind of set the scene with currently where we are today. And then we're going to move to the vision for the future. And so then the idea will be that each of our panelists will speak about a dimension of what this future vision looks like. It will be a long journey, they always are, to get from where we are to taking advantage of more advanced technologies. We tend to move at the speed of safety in aviation. So what we want to do is embrace, as others have said, I characterize them as this new community of users who are using new technologies that have been used by other industries, but certainly new to aviation. And they're bringing brand new business models, really exciting. But we have to balance all of that with our legacy airspace users. So life is all about balance. So we're going to start with current, a little bit of a picture about the future, and then we'll have some Q&A for the panelists and some time for you all to submit questions using Slido. So with that, I will have us go kind of around the room, introduce ourselves.
Okay, hello everybody. So Carol introduced me as an artist, but I typically introduce myself as a systems engineer from Honeywell. I've been with Honeywell for 19 years now, and most of the time I've been working on cockpit, SATCOM, and data link technology-related projects.
Good morning, everyone. I am Luc Amberger, senior expert for communication and connectivity in Airbus. I have been working in connectivity for more than 20 years, and so always involved in the new projects to enhance and modernize connectivity. and I am also chair of the working group 78, EUROCAE 78, in charge of the air traffic service data link standards.
Good morning, everyone. My name is Christopher Mishek. I am here representing the European Union Aviation Safety Agency. I'm working there since July of last year, actually new as an ATM ANS expert, but I'm not new to the agency. I joined in 2012, where I was working as an avionics systems expert on the certification of equipment on the aircraft. And I'm one of the technical contributors to the future connectivity for aviation aspect. And before that, I spent a lot of time in industry as well. So for me, it's interesting to see, in fact, you know, you come into the different areas and you think you know a lot, and I've learned that I don't know as much as I thought I did.
Hello, my name is Peter Leidold from Frequentis. I'm leading the Network Solutions department in Frequentis, and it is responsibility working on LDACs and the future communication infrastructure as an open framework concept.
Hello, everybody. My name is Raúl Berrocal. I work for INDRA. I'm chief architect. I'm mainly involved in the design or the architecture of the ATM systems. For example, ITEC, where we are developing.
Okay, yes. Okay, so Radek is going to help us get the conversation started.
Okay, so I will try to do the impossible and explain in 2 minutes. 12 minutes and 2 slides, where we are today in terms of aviation connectivity and where we want to go in the future. Why is it moving? Okay, so to do that, it's useful to think about the aircraft as being split into 3 domains. So first, we have something we call aircraft control domain. This is where we have all these systems required to safely fly the aircraft. So things like flight management system, navigation systems, cockpit displays, etc. Next, we have something we call aircraft or airline information services domain, or ICE domain. This is where we have systems that are still used by the crew or by the airlines or by the aircraft manufacturers, but only to improve efficiency or comfort of the operations. These systems do not have safety impact on the aircraft's operation. And last but not least, we have something we call Passengers Information and Entertainment Services domains, or PISE domain. This is where we have onboard Wi-Fi and other systems used by the passengers. Now, back to the aircraft control domain, because that's most related to the air traffic management we've heard about on the previous speeches. We have 2 applications that are used to control air traffic management today. They are called Controller Pilot Data Link Communication, CPDLC, at the top here. We have something called Automatic Dependent Surveillance Contract, or ADSC. So the first CPDLC is essentially a messaging application, something like WhatsApp or SMS that you can use on your smartphone, but between pilots and controllers. It allows them to issue clearances and do other stuff like that. ADSC is another application that is allowing controllers to retrieve automatically, without pilot's intervention, real-time information from the aircraft. The most famous is the 4D trajectory calculated by the FMS that is going to be mandated in Europe from 2028. Unfortunately, for historical reasons, we do have 2 flavors of these applications. As you can see up here, we have in Europe, we have applications using something we call ATNOSI, so network technology coming from 1990s that is used only in Europe and only in aviation, nowhere else. Elsewhere in the world, we are using even older technology. We are using something called ACARS, which is essentially a messaging technology developed or originally conceived in the 1970s. And it's still being used and made great services to aviation, no doubt about that. And because we have these 2 technologies, we need 2 backbone networks or backbone infrastructures on the ground. So the systems that connect everything on the ground. So we need ATNOSI backbone and ACARS backbone. And for each, we may have more than one service provider. So we have SITA provider, SITA backbone network, Collins backbone network. And then we have something I call on this picture safety air-ground links. So these are the links, air-ground links that have been developed, certified, and proven to meet the safety requirements, and they support these legacy technologies like ATNOSI and ACARS. And we have 3 today. We have Inmarsat Satcom, Iridium Satcom, and VHF Data Link Mode 2 or VDL Mode 2. Inmarsat and VDL Mode 2 support both OSI and ACARS. Iridium is used primarily in oceanic airspace and supports ACARS. Now, when I speak about ACARS and ATNOSIs and network technologies or messaging technologies, to understand what they do, they essentially glue all this together. So they allow our ground end systems, ATCs, to link through the ground-ground infrastructure to the air-ground service providers like Inmarsat, Iridium, and find the right aircraft and send the messages to the right aircraft. It's like internet protocols in your smartphones, in your computers. When you send email from your smartphone to your boss in the office, it needs to go through the internet protocol-based network. But instead of internet protocols, we are using ACARS and ATNOSI. We also do have another set of applications that is running in the aircraft control domain. We call them airlines operational control. These are applications used by the airlines. There can be also maintenance and other applications. They are not safety critical typically, but they still run in the aircraft control domain, and they do use the ACARS messaging technology. Now, when we look at the bottom of the picture, at the passengers, it's a little bit unfair because the passengers, they have actually better links than we have in the cockpit. So the links that the passengers can use, they are really state-of-the-art broadband links based on internet protocols, have much higher throughput, better latency. You can run modern applications, upload, download files, do things that we can't do in the cockpit today. These links and these technologies can also be used by the ICE domain. For electronic flight bag. So if you have electronic flight bag, an iPad essentially with application downloaded from App Store, you can use all the links available on the aircraft. So this is where we are today. Now, I'll just try to explain where we want to go to in the future. The first, and to me the most important and biggest thing that's happening is we want to replace those legacy network technologies, ATNOSI and ACARS, by something we call Internet Protocol Suite, or IPS. And we could talk for hours why we want to do it, how is it beneficial, etc. I won't spend time on that now. But this is the first big step we want to do. The next big step, potentially, we will do is add additional air-ground safety link. The reason is that VHF data link is causing a lot of the troubles that we see in Europe with data link today are caused not by the ATNOSI protocol stack, the network technology, but by the VHF data link itself. So LDAX would be kind of next generation VHF terrestrial system operating in L-band, better latency, more throughput, better security, etc. The other thing we want to do in the future is something we call a hyper-connected ATM. And frankly speaking, I think we need to come up with a better term because hyper-connected ATM is being interpreted in so many different ways. But when we talk about it here in this forum, what we mean is enable the connectivity from the aircraft control domain through the high-performance public or non-safety links that are today available only for cabin. So all the applications that we run in the aircraft control domain can run through the non-safety links. And then, you may not have seen it, but B2 popped up here. So yes, we keep developing new applications, new versions of CPDLC and ADSC. But we also, when we implement IPS and hyperconnectivity, it will open door for a whole new set of applications in the aircraft control domain. So this is where we want to go to, but we also know that we need to accommodate transition, which means we need to have the future aircraft IPS-based. We need to have it talking to the legacy ATNOSI and ACARS ground systems, like today's ATCs. And we also similarly need to have the legacy aircraft that can only speak ATNOSI or ACARS. We need to have that aircraft being able to talk to the IPS end systems on the ground. And to do that, we, not Honeywell, but other companies, are developing what I call adaptation gateways that will translate different protocols on the ground. Gateways. Yeah, and we expect that the gateways may not be available right from the start everywhere, so we may need to have still during the transition period dual-stack aircraft that will support IPS and ACARS. Just like today we have OSI and ACARS in the aircraft, we have IPS and ACARS in the aircraft. And I think that's it. Oh yeah, I just mentioned that we may also have the hyperconnectivity I showed here for IPS, but we may decide to apply it also for ACARS and ATNOSI, so we may also decide to enable ATNOSI and ACARS connectivity through the public broadband links. And I think that's it, yeah. Okay, so now we can move to discussion. In the end, there will be a quiz.
See see how multi-talented he is? And he even told you he had 12 minutes for these 2 slides.
Do we keep it?
These slides are going to be made available, I think it's about a week after the symposium, I understand. And then we also included a slide that is kind of a bit of a decoder ring for all of you to see what all of these acronyms actually mean. So let's start with Luke, who is obviously an aircraft manufacturer. And so if you can walk us through how the aircraft manufacturers are going to approach this long journey toward future connectivity, that would be helpful.
Yes? Very good.
Yes.
Yes. So our approach toward future connectivity is key. Indeed, until now, for us, connectivity was mainly safety communications, mandatory and regulatory communications, and all what was linked to broadband links was more on the hand of our customers for passengers, more or less. But as you know, our airplanes are becoming fully digital, and as it was said, being digital without connectivity means nothing. We are able now to export a lot of data, so we need links to export this data. For safety, we see now that with the advanced ATM services, our flight management system can provide to the ground a lot of valuable data to make the control, the air traffic management more predictable. But also for cockpit operations, maintenance operations, we have a lot of data. We aim at making it available to everyone to make sure that we can operate our airplanes more easily in the future. And we approach the connectivity as a must-have capability, basic capability, but also as an efficient, as a cost-efficient capability. The challenge is to make sure that our airplanes that are flying everywhere are capable to connect everywhere, but also we see the target looks quite complex and we cannot afford to implement everything. So our goal is really to converge to an efficient and optimized connectivity.
Thank you, Luke. Let's go over to Peter. Radek mentioned LDACs as being a really key advancement to realizing this vision for future connectivity. So how about if you walk us through that?
Mm-hmm. Okay, I would like to connect what Klaus Meyer said. We need in the second step connectivity, but the important thing, we don't need any connectivity. We have here special performance criteria to make this really useful. So when we look in the ground infrastructure, we managed mostly across Europe now, I would say to rely on gigabit fiber connections and in remote areas on radio links, specialized radio links. But when we look at, I call it the last mile, the connectivity to the airplane, it's like we are still relying on this a few kilobit technology that is based on, I would say, in the initial internet area with modem tones, and even worse, we put on a VHF channel. So that's a very challenging environment, and maybe this also relates to another question later, but we are still investing a lot of money into optimizing this data link, where probably it would be better or more wisely invested into our future. So how does LDACs play into this now? So LDACs is more or less based on a 4G-like technology, optimized for the use in air traffic management. It has a cell-based structure. It provides, in the best case, a couple of megabit data bandwidth. It's a second safety link, you could say. So SATCOM is one of the safety links, and LDACs can be the second safety link. And when we compare it with VDL Mode 2, the infrastructure of the VDL Mode 2, at least on the ground, can be reused. So putting this infrastructure in place is I would say, a simple task, and maybe Luke later comments the airplane is surely here the more difficult part. So also with LDACs comes security concept. We have authentication, we have encryption, all this embedded into it. We also get additional features we always talk about when we think about LDACs, the connectivity, But with LDACs, we also do have the chance that we get navigation and surveillance features that would be for future research to make this infrastructure more resilient, not just for data connectivity, but also for navigation purposes. LDACs is also is an open standard, and therefore it will allow to have competition, but also to have compatibility across its deployment. Yeah, and it's robust, so it has no centralized components. That's probably the main difference to SATCOM or other telecommunication infrastructures. It can be really set up in a decentralized way and is not so susceptible to jamming that happens nowadays a lot. About the progress in the US, surely the US is here a key player. And Europe is surely more driven here by the capacity crunch of VDL Mode 2. But we also now see quite a lot of interest in the US. We are working together with Boeing, with Honeywell, but also with Collins and with many others. And we are confident that it also gets more traction there, especially when I think about the future performance requirements we have. Let's think about single pilot operation, but also about the UAVs entering the airspace where you want to have a command and control link that is really reliable. Yeah. And last, I want to mention that we published together with Rohde & Schwarz, with airlines and other players recently a very interesting white paper that captures all these areas.
Thank you, Peter. So, Raul, how does the vision for future connectivity impact flight planning and navigation?
Well, hello. Yeah,
it works. I think it works.
It does work.
Okay. For the planning and navigation, well, the technological modernization of the data link applications allows will be let's say a key enabler for the transformation towards the trajectory-based operations concept that is what we are exploring in the collaboration in Europe, the TBO. The advanced data link capabilities will allow that each aircraft will be continuously connected and sharing its trajectory with the relevant air traffic service units, so that it can enable that there will be a single and common trajectory between all the involved factors. So in that case, flight planning will be able to be improved by taking into account the individual performance characteristics of each aircraft, and also the user preferences, also the real-time traffic, and the meteorological conditions throughout the network. With that information, then air traffic control will be able to offer better routines to sequence aircraft far in advance, and that's all. And then regarding the trajectory-based operation, that is the real impact supported by data link, it is mainly supported by two aspects. On one side is the exchange and use of the ADSC, one of the application, the extended projected profile, the intention information, and on the other side, the support for complex multi-element clearances, CPDLC clearances, that the flight crew will be able to load into the equipment, into the aircraft equipment, and this will then provide both things. Will provide the air traffic control with a more accurate picture of the aircraft intentions, and will improve significantly the flight predictability. So main of the benefits that can be achieved with these things are, for example, the reduction of the human errors, as the dialogues will be digitalized, and also showing automatically any discrepancies, warnings on any discrepancies between the air and the ground trajectories. Also will be an improve in the situational awareness and the safety, because there will be a more accurate picture of the aircraft intentions and also the sector loads, and will be better information in order to improve the conflict detection and resolution activities. Also, there will be better air traffic management, facilitating the continuous descent operations, also maximizing the time at cruising level and reducing the number of descent steps. And also, finally, also improving the productivity between the controllers and the flight crew. As the aircraft intentions are automatically downlinked, there will be fewer requests or interventions from the pilot, and it will result in a more seamless and efficient communications.
Thank you, Raul. So Chris, EASA is one of the authors of the Future Connectivity in Aviation paper that was published in October of 2022. So now a really easy question for you. What are the regulatory challenges associated with implementation, integration of the future data link connectivity as Radek had illustrated for everyone?
Thank you, Carol. You know, it's not an unusual question. I think we get asked that all the time, and not just in this context. EASA, at our core, we are safety. That is our core mission. And the question I've had, and we've had discussions with colleagues in recent days about how do you support innovation, how do you foster the future, but maintain a safe system. When you look at the slide that Radek presented, you see the complexity. You have a complex system. And so now you look at this, and the idea is you want to improve or change it, but it's so complex, you have to make sure that the safety is maintained. And I think the challenge for future connectivity for all the aviation providers is that we have a time crunch. Klaus had earlier showed you this graphic from Eurocontrol, where you could see that there is going to be a point at which the system cannot accommodate the demands. And Luc had mentioned that there are two primary demands. You've got increased usage by the ATM community. Yeah? They need to improve the efficiency of their operations, but you have increased usage by the flying aircraft. They have either engine data, they have other information they want to be sending to or from their operations. And in Europe here, all of those right now are going through the VDL mode 2 for the most part. And they're competing for this, and it creates a bottleneck. So now, how do you deal with it, knowing that in 2035, that's the bottleneck? And so for the agency's role, I like to just say that, you know, regulation doesn't prevent innovation, but regulation makes sure that it's introduced in a controlled manner and that our safety is maintained. With regard to the white paper, you know, I think that was an initiative from the executives of the FAA and EASA and Boeing and Airbus. And I think there it was the realization that you've got a devilish problem in front of us. And by 2035, we've got this blocking point. And what can we do in this time frame? And the idea is, they knew that it wasn't involving all the stakeholders, but the idea there was, could this group of people with expertise and knowledge come together and agree on a common vision for the future? And if you're interested, that white paper is out. It's available on the public website through EASA and I think the other organizations. It's also downloadable, I think, from the previous summit that EUROCAE and RTCA hosted last year. And you can see the more detailed discussion there. But I think really the point here is that from that working group, that task force, what came out of it is, one, a reinforcement of a multi-link environment in the future. So Peter talked about LDAX. That's one of the links. We have the VDL mode 2. That's an existing link. Radek had shown you all the other links in the network and the progression from going from what we have now at the ATM OSI protocols and switching over to the IPS in the future, maintaining B2. Those things are all necessary. But what the task force did, that I think personally is the innovative part, is to say, look, other industries are modernizing, other industries are creating other links. And wouldn't it be interesting, couldn't we use these commercial links, which would be non-safety links, to transport some of the safety critical messages we need to relieve the pressure in the short term? And so that's the innovation here, and that's called this hyper-connected ATM concept, but it's really this idea of using commercial links to transmit safety information. And that's the trick, right? So for all of us here on the panel who've been involved with it, Luc on my right, he's very deeply aware of it. There's a lot of tricky parts there, and I think if you look just from the hyper-connected ATM concept, the potential payback is huge, if it can happen. But if you really look at it, what you're looking at is something that's considered to be around technology readiness level, TR level 2 or maybe 3. And when you look at something like LDAX, it's further along down the line. But there, it's an investment strategy. And now you've got these kind of balancing act, you know, which one is it? And we don't know. And that's why through the agency, one of the things we want to do is propose additional activities in the future. So we recently proposed a working paper to go to ICAO. That's going to ask the air navigation panel to bring this on board as a work paper. And the idea there is to really bring attention to these concepts of a multi-link environment and to ask the aviation community to get together and really push these things forward. And I think that's the challenge from a regulated standpoint, is to foster that innovation, but making sure that we're preserving the safety in the process.
Thank you, Chris. Radek, back to you. Let's continue the theme of this multi-link approach. So how will SATCOM address some of the shortcomings of data link?
Okay, so I'm obviously biased because I've been working on SATCOM for quite a few years now. But if I just list the advantages that I see, so first obvious advantage is the coverage, right? So if you have a SATCOM system, typically it has global or near global coverage. Second advantage associated to that is that we are not planning to build new SATCOM systems dedicated for aviations. We are using systems that are already there, and they are used with other markets like maritime, military in some cases, civil. So we are not investing into building new constellations. We are just modifying, upgrading, and overlaying the existing constellations with new technologies that allow us to run OSI, IPS, ACARS, cockpit voice through the existing SATCOM systems. Third advantage is capacity. It's a relative term because, like, if we look at the safety SATCOM links that operate in L-band, they are still narrowband in today's measures. But compared to VHF data link, which we have today, it's still order of magnitude more capacity, right? So, and fourth and last advantage I could mention is security. It's a little bit sensitive topic, but those familiar with how OSI, ACARS, and VDL-Mode work know that there is no like real cyber security implemented. There is no encryption, there is no encoding. With SATCOM, you get at least one layer of security, so that it's not easy to eavesdrop or even spoof when you are sending data over SATCOM. So these are the obvious advantages, and then when you pair it with the Internet Protocol suite, that allows you to develop a whole new set of applications because it's not just messaging applications anymore. You can send files, you can do other things with IPS that are difficult to do with ACARS. Then SATCOM will be the underlying enabler. So if you think about the parallel that I like to use is, it's not so much SATCOM specific, it's also related to the IPS that goes on top of it. What we have, the way we control air traffic today through data link is essentially sending text messages. It's not much more than sending, like when we used to have the old phones, like button phones, when you could only make phone calls and send SMS. This is what we have in aviation for air traffic control today. When we move to SATCOM and then broadband SATCOM and with IPS, then you will be able to move to something that is closer to what we have with our smartphones today. So applications that are always connected, that can send bigger volumes of data securely to designated servers on the ground. Okay, that's it.
Thank you. Luc, continuing the theme here on security. So how do the aircraft manufacturers ensure the security and integrity of the link on board the aircraft?
So it's a very good question, because by being more connected, more digital, obviously, security now is a must. We are responsible to have a safe, secure aircraft anyway. And now, as we are connected, the cockpit is connected for safety. And tomorrow, with more modern internet-based protocol, which are considered as more sensible to security threats, the VFB is connected. Well, almost all aircraft capabilities are functions are connected. And today it comes with obviously a comprehensive security framework and solution. So we aim at protecting two things, in fact. Modern air traffic management, modern data links needs to be protected. So we protect the data link information itself, the messages. We make sure that they are coming from the center who is supposed to send a message, they are authenticated. So this is the first objective, and modern technologies like IPS will provide embedded security. We cannot imagine to modernize the network technology without security. For us, it's a basic. But then, on top of that, we have also to continue to protect our avionics. As we are connected, more and more connected, our flight management system is connected. So the core of the avionics, which is in charge of flying the aircraft, is connected. Here we have something which needs to really be fully protected. And this is our duty. So we implement additional security measures today. And the regulation asks more and more, which is normal, to protect the airplane. So any new development starts with a comprehensive security risk analysis. And all along the development, we develop security measures, we validate, verify security measures. So it's, for us, there is no safety if we cannot demonstrate that our airplane is secure. There are standards, so we apply standards, and EUROCAE is also developing standards for security. It's a very good way to implement something which is robust, state-of-the-art. So we use standards, and then we use also standard solution, but also methodologies that we apply to make sure that our systems are well designed from the beginning to be robust. So again, security for us, it's now a key capability, and we can hear somewhere that it would be more or less easy to access an aircraft. We see movies and so on, but I can tell you that I think our airplanes are well protected, and we do what we have to make sure they are.
Thank you. Peter, back over to you. Can you share with the participants some of the future developments in data link in terms of ATM, air traffic management?
Mm-hmm. So Frequentis is mostly on the ground side of things. So one of our biggest development research topic is the future communication infrastructure that we see as an open framework to integrate all these different technologies that have been mentioned here today. And now in the next phases, the validation of this interworking is important, the validation of the security concept. But in general, in my opinion, the standardization and the research is now quite advanced. So the most important next step is to move into actual flight testing of all these technologies. And SATCOM here is very much advanced and has already EASA certification. But when, for example, to mention LDAX, there has been experimental flight tests performed, but this was basically performed with ground radios in the airplane. So I would say the ground infrastructure is far advanced, but when we look into investment and support of funding, I think the airborne side is now an important part to move forward here. And yeah, so digital sky demonstrator, like for SATCOM, should be the next step to move the other technology forward, also surely for hyperconnected.
Thank you. Raul, over to you. So is it possible that this vision for future connectivity in aviation can support the green side of air traffic management in terms of sustainability?
Yes, of course. The evolution of the data link applications will help to reduce the environmental impact by, for example, reducing the taxi delays on the ground, or by providing optimized trajectories for en route. So in this case, the approach in general is through the digitalization. No? And digitalization will need data, and with that data, we can apply the more modern technologies, like, for example, the data analytics, the machine learning, or the artificial intelligence, that will help to improve the planning and the implementation of environmentally optimized flight routes that will reduce the CO or CO2 emissions in order to reduce the impact in the environment. So it will be possible with the new technologies to optimize the impact on the environment.
Thank you. Mark, I don't see any questions from Slido. Is that correct? Okay. Okay, so we'll walk through a couple of these. Radek, there's one very specifically for you.
About the picture?
Yes, it is. How much does it cost? I'm kidding. Okay, so Radek, what role does voice communication play in that wonderful picture? You may have said it and I missed it.
Yeah, no, I haven't said anything about voice. The reason is I was not able to fit it into that picture, which was crowded enough already. So voice to me is still a little bit aside. I think that until I retire, we will keep using VHF voice just because of how simple it is and how reliable it is. Then, I mean, in continental airspace. Obviously, in oceanic airspace, we keep using SAT voice, SATCOM voice, and HF voice. What I hope is that we will see sooner rather than later is moving away from HF voice and switching to SATCOM voice only and SATCOM data link only, so without HF, as acceptable means of communication in the oceanic procedural airspace. That's one big change I'm hoping to see before I retire, well before I retire. The other aspect that is being discussed is how and if could we use digital voice in the continental airspace. And we could talk about it for a very long time, so all I will say is that yes, I see obvious benefits of using digital voice so that you don't have to switch frequencies you fly between different VHF ground stations. You can be connected to essentially like something like Microsoft Teams or WebEx. You can connect group of aircraft to one conferencing room and you could come up with new operational concepts. The tricky part is the underlying technology, right? We can't use VHF data link for that, obviously. We could use LDACs, and that's one of the studies. So that's one of the reasons why LDACs could win in the end, from my perspective, that if it would support digital voice and if we would find good use cases for digital voice, then yeah, that could drive LDACs endorsement as well. And yeah, beyond that, SATCOM voice, I think, will never really be used in continental airspace, maybe only as a backup because of the latency and the associated costs with that.
Thank you.
If I didn't answer the question, just catch me in the corridor and I will try to answer it better.
He's signing autographs at the networking session. Okay, Chris, I have a really easy one for you today.
And I'm sure it's not.
Don't you love my setup? Okay, any consideration of a mandate to ensure a new infrastructure, parens, IPS, potentially LDACs, is ready to address the saturation expected in 2035?
I asked you that by email recently.
Yeah, he did. If you didn't hear it, Radek sent me an email prior to the conference asking exactly this question, and I forwarded it to colleagues. You know, I think what I can say is this. A mandate is, this is a big thing. Yeah? If an agency is going to put forward a mandate, we have to be sure that there's really an issue. We have to be sure that what we are mandating is going to solve it and it's possible. And these are big asks. So the agency isn't going to move forward with a mandate until there's some certainty there. And part of that also has to be, you know, we don't impose it on industry. These are things that have to be somehow done collaboratively and collectively, because if it's not, if I give you an extreme example, if the agency were to mandate that, for example, Luke, I'm going to tell you, you have to do something, and the answer comes back, well, I can't, not in the time frame you want. So we can't simply just do a blanket mandate. And in terms of IPS, I think that's a more practical question. I think really on our side, we recognize that we need to have an IPS standard. If a lot of the things that we're talking about want to move forward, that's one of the basic things that we as an agency realize that we have to have. A mandate, I don't know. And I've not heard anything about that at the moment. And the other thing too that we know is a standard for B2. So I'm getting ahead of myself. I know that's another part we'll probably talk about, but standards and the importance of those play a big role in it. And I hope we get a chance to talk about that too in the time remaining.
Thank you, Chris. I have a question about TBO. Raul, do you want to take that one? Okay, well, TBO applications also see use in lower-end terminal airspace. And there's a follow-up question to that. Can digital communication replace voice communication in terms of speed of transmission?
Well, yes, the data link application normally for the lower airspace are not mandated, no? And so that will be the evolution that will be I understand in the future. So that will be the support for that will need to evolve in order to be also used for the lower airspace. At the end is to have a trajectory based operations across the different airspaces, no, from upper to lower. But as I see that there is still a constraint in the data link communication for lower that will be evolving in the future in order to achieve this seamless operation.
Thank you. Okay, I have a question. Is there an augmented risk of spoofing and jamming? Who would like to take that? Luke, I think it might have your name on it.
It is true that we see more and more GNSS jamming situations everywhere. So the risk is increasing. Indeed, it's even not a risk. We see jamming, and we are trying to manage it by first, from an operational perspective, explaining to our crews how to manage the situation, how to detect the jamming situations. And then we are trying in the standards to improve the systems to make it more robust to jamming. So it's something we know, it happened. It takes some time to the urgency is to explain how to manage it. And the second step is to react and to have more robust systems. So we take it very seriously. We assess always if there is a safety impact. We are currently, I think there is an EASA carry running. So we are asking to assess the safety consequences of this kind of threats. And we take measures, either operational or for our future systems to protect against this malicious jamming or spoofing situation. It's something which is almost impossible to just prevent. So we do our best to be protected as much as possible.
Yeah, I would just compliment, because I think just yesterday I read an article that there was a flight from Thailand to Israel, I believe. And because we are talking about connectivity, so communications, and I think about Syria or somewhere, they started getting spoofed controllers. Somebody pretended to be controller, and they were giving them fake commands, asking them to land on a different aircraft. They were trying to divert the aircraft to another airport. And that's clearly possible with VHF voice, with HF voice. It's more complicated with data link over VHF, but it will be possible there as well. Nothing happened because the messages were, or the phraseology that is being used, or the data link messages are so simple that you can easily control, you can understand, and you can easily detect, okay, this doesn't look right. So then you may use other means, like if you would receive spoofed data link message, you could use VHF voice to contact the controller, verify what's happening, and then stop using data link, or other way around. If you hear somebody pretending to be controlled on VHF, you may try to use other means of communication. So it's when the phraseology is simple enough, it's easy to detect that something is going wrong. But when we move to more advanced usage of data link, then the spoofing could become really, really critical. If we think about, like, somebody sending for the trajectory or like required time of arrival to the FMS, or flight plan updates to the FMS, that could become really dangerous. And that's why I think that the spoofing we have to pay much more attention to it as we move to more complex applications from what we have today. And that's what IPS and SATCOM would bring you, essentially.
Thank you. Oh, Chris?
I want to get a chance on that one too. I think you all can see, even from the diagram you saw earlier, that I think in the language of our cybersecurity colleagues, they talk about an attack surface, and it's quite large as it is. And when we move into a digitalized environment, that surface grows. And what I wanted to just say is that the agency is aware. We have already activities underway where we're looking at data and information security aspects. We have Part IS available, and it's looking at exactly these questions. So spoofing, GPS jamming, those are only some of the areas. Yeah, there's other ones as well. And then I think I might give a small call out to a colleague who's going to be doing a later panel. I think that's part of the discussion they're having is also on cybersecurity and data security. So if you're interested in it, tune in.
Thank you. Okay, so we have a question about hyper-connected ATM. So I'll read the question and you all can decide who's going to answer it. But then as a follow-up, Radek, you had mentioned when you were presenting the graphics that you do not favor that term, and maybe you can share with us why that is the case, because it is in fact in the paper, the future connectivity for aviation paper. So let me tell you what the question is from the participants. Do you think hyper-connected ATM becomes unnecessary if LDACs are accepted by operators and airframe manufacturers? So who would like to answer that? Chris. Well, both of you, if you would like.
I can try a first answer. So,
okay.
With the idea of having multi-link in Europe, the idea is to have a set of available technologies to make sure we have sufficient capacity to cover the needs, but also to let some freedom to take into account economical situations, preferences, and so on. So hyper-connected ATM is an additional capacity. LDAX is an additional capacity. So do we have to choose and to say, if I have LDAX, then maybe I do not need hyper-connected ATM, or the contrary? In fact, the objective for us is to have sufficient capacity at the right moment. So we believe, for example, hyper-connected ATM can be deployed maybe in a reasonable time frame, maybe LDAX as well, but we have to manage the transition. We know that technologies takes time to deploy, and the idea is to have as many alternatives as possible. So I'm not sure the question is one or the other. In the end, the situation will be driven by economical constraints, by many factors, and hopefully we will have global solutions. For example, LDAX would be good if it would be also supported in other regions than Europe. Hyper-connected ATM, by definition, is global. So the decision will be on all these criteria. Not sure they are like this in such competition.
In fact, I would agree 100% with Luc just said. I tried to say that earlier, and if I didn't make it clear, I try again. It's really a multi-link environment. So we at the agency, along with the task force, we're saying that hyperconnectivity in this concept, this is very promising. And as I said, that if it pays out, that's a really massive payout. But as I said, its maturity level is lower, for example, than other technologies, and LDAX is one of those. So when you ask, well, if it succeeds, does that mean hyperconnected ATM isn't necessary? I think that's going to be driven by the market. Yeah, what becomes available in the time frame that we need it, that's attractive to the operators and users of that link. So from our side at the agency, we just want to make sure that whatever is available meets the needs of the users and it remains safe. And then we look to our industry colleagues to help us understand which one is going to be the one that they use.
Just a few more words on this. I think it's hyper-connected ATM concept, the one that we talk about here, is not necessarily only for the safety-critical application. So it's not just for next-generation CPDLC and ADSC. You can use it for any type of application that runs in the aircraft control domain. So if you want to, for example, download some large volumes of data from your flight radar, from your flight recorders, you want to have maybe single pilot operations assisted from the ground. So if you have these types of new applications, then hyper-connected ATM may give you the capacity that you need. So yeah, LDAX will have to be there for the air traffic control, maybe, to support, to sort of evolve from VDL mode 2. But by offering hyperconnectivity ATM and IPS into the aircraft control domain, as I said before, we are opening the door essentially to development of whole new applications that we can't maybe even think of today in the long run.
Maybe just a very last point on this one is that it's not a full competition because by definition, hyperconnectivity ATM needs to have a safety bandwidth available and sufficient safety bandwidth. So it's not one or the other. You still need sufficient capacity on the safety links to make the concept feasible. So that's why we need both.
Okay, thank you. Okay, in the interest of time, we're going to wrap up the panel. So we're going to close out with the same question for each of our esteemed panelists here. So obviously, it's going to be a long journey to transition from where we are today to the vision that's in the paper. So if each of you could share your thoughts on any risk, any particular risk or risks you see relative to this transition, and then how might standards development organizations play a role in mitigating that risk? Sure.
Okay, so there are always risks in aviation, and I think the biggest risk is that some of the smartest engineers run out of patience because things are moving so slowly, right? And there is not much we can do about it just to accelerate. I think it's very difficult. We just need to somehow all adapt to the fact that aerospace is very slow, and then data link and communications particularly, because you need to have so many stakeholders agreeing. So the slowness of the evolution, I think that's one of the biggest risks that will then make it for the investors say, okay, it's 10 years out, well, I won't invest. So that's, I think, one of the biggest risks. And what was the other part of the question? Sorry.
How might standards help?
Oh, how might standards help? Yeah, so I think standards are already helping now by developing standards for things like IPS, LDAX, etc. I think, to me particularly, the near to midterm activity that needs to start thinking about what and how should be standardized in hyperconnected ATM. That's a gap that we have at the moment that we need to fill in standardization bodies.
Yeah, I fully support what you said, Radek. I think for me, the risk is not technical. The risk is that as we are starting from different situations in different regions, the risk is that some regions are going too slow, are not moving, because obviously to move toward this objective, investments are necessary. And what we can do from a standardization perspective is to have a clear technical solution, simple solution as much as possible, and cost-effective solutions to make them attractive. The risk is to not move because the target is too expensive, too complex. So simplifying as much as possible IPS, simplifying the target is to me the best way to make sure people can invest and deploy it. And in that, for this objective, our standards have really a responsibility.
You know, I think, like Radek said, anyone who works in this industry for any amount of time realizes there's risks everywhere. And when we're talking about future connectivity, you can find any number of risks that could let's say, upset your progress towards your goal or your destination. And I think for me, personally, if you ask me what the primary risk is, it's time. Time is moving, and I think we all see that something like this that has been in place for so many years, that is so trusted, it's difficult to move, yeah? And the time is ticking. So for us, standardization is a key, because that is where the agreement is found. That's where you all have predictability on what is expected and what can be done. And as a regulator, we used to do an exercise when I was working in the agency. We did some of the standards administration activities, and we were reporting to the executive director. Each year, when a new standard was published, we would say, hey, we have someone from EASA working on that standard, and that standard is being quoted in one of our regulations or a guidance material. And that's critical for us, because we don't want to write that material for you, the industry. We want that material to be developed by industry and useful in the regulation. Yeah? And so for me, we have to have standards to help us address the risk, but again, the time that's ticking is the bigger one, and personally, I don't have an answer for that. I think it just is apparent on all of us who are working in the industry to recognize that we have to move forward and find a way, working collaboratively, to get to that objective.
Okay, I can only agree to what was said before. One of the risks from business side of things is there is from CESAR provided a really good framework for the research of the technologies, and they are reaching now a level of maturity where the research projects are stopping, but also business is far away, and so there is a gap in between that needs to be bridged. Otherwise, a lot of activities are going down to a low level of activity, and this we really need to prevent to shorten this gap between where we have achieved a certain maturity until we can start with deployments, maybe reference deployments, etc., to keep this going.
Okay, from the ATM systems point of view, the approach is go to digitalization. Digitalization will imply higher levels of automation, and automation requires high throughput of data. So in that case, we will require very demanding requirements to the network connectivity, in that case to be supported by a multi-link environment. So the ATM system will need to ensure that this multi-link environment will support the ever more demanding characteristics of the network. In that case, for availability, for bandwidth, and for latency. So there will be I think that is the main risk, to ensure that, because ATM system will rely more and more on this quality of the network. And then standardization, well, for ATM system there are already standards for the baseline 2, for example, for data link applications, and any evolution of that will require more more bandwidth and more performance from the network.
Thank you. Does anyone want to make any closing remarks? Nope. Okay.
Yeah, maybe just one. I just again want to thank RTCA and EUROCAE for bringing attention to the topic. The summit that happened last year was the first one that I was aware of, and this is a follow-up to it, and it's really encouraging to see that, you know, the enthusiasm behind pursuing that goal, that objective, is still there. And so I just wanted to say thank you to Anna van Goorte, and then also to the people at RTCA, Carol, and yourself for hosting the panel.
Maybe one more thing. Thank you. No, just would like to encourage everybody, really, if you want to ask something, or if you have some opinions, particularly on IPS or hyperconnectivity or LDACs for peer, just really come and ask us. You know, I'm really would be happy to discuss in more details anything that we have shown here, or try to answer.
Okay, so there were more questions that came in from all of you, and I apologize we didn't get to them, but each of our panelists will be here today, so I do encourage you to reach out to them, and with no time limits, right? You could talk forever, right?
Oh, yeah.
So thanks to all of you, and again, the slides will be available in about a week, and if you could join me in recognizing our esteemed panelists today. Thank you. Great job.
Thank you very much, Carol, and thanks to all of the panelists for this very interesting and inspiring discussions, and those very nice last words also on EUROCAE and RTCA activities in this area. Well, we'll get to some of the topics that were raised in the next flash talk, and also in one of the sessions after lunch. Before going there, I would like to give Skyguide again the floor, and do this through a video that will show us a little bit the typical day within Swiss skies, and well, enjoy watching. Thank you again to Skyguide for providing this video. I think it shows very nicely how things are working and illustrates a number of the points that Klaus was mentioning in his speech earlier on. I'd like to move now to the first flash talk of the symposium, and Mark will introduce it to us. Thank you, Mark.
So we're now going to have a flash talk on spectrum and coexistence between mobile networks and aviation. So EUROCAE Working Group 124 kicked off joint work with RTCA Special Committee 242 in March 2020. It was established to develop guidance material on spectrum use and best practices in aviation whilst respecting the necessary safety margins. The guidance will support the aviation industry in working collaboratively with non-aviation spectrum users, ensuring safe integration of new technology. The group is also working on a report that will be the reference for non-aerospace spectrum stakeholders to support effective and successful discussions with the aerospace industry. So this flash talk is from the perspective of the non-aviation spectrum users on ensuring safe integration of new technologies that are so important to the advancement of our collective industries. So I'm very welcome to welcome Michael Kramer from Intel to present this talk. So Michael is Director of Communications Policy, Europe, Middle East, Africa, at Intel's Global Government Affairs Group, where he oversees Intel's technical regulatory activities on spectrum strategy in Europe on matters relevant to Intel's wireless products. He works closely with Intel's business units to implement Intel's spectrum strategy in the CEPT and ITUR, through engagement with industry and regulators to ensure timely and adequate availability of spectrum resources in support of Intel product plans. So as part of his participation in these regulatory activities, he chairs various working groups within CEPT and ITUR. So thank you, Michael, for presenting the flash talk from this perspective of non-aviation users, and I'm sure you'll explain initially what CEPT actually means. So thank you, Michael.
How do you move the slides now? The slides are there. Yes, hello. I found it. Thanks. So it is me between you and lunch. I'll try to make that brief and informative. And look at something that is a bit maybe outside of the other parts of your agenda, spectrum regulation. Given that the aviation industry, as Mark said, uses many different frequency bands and applications, so spectrum regulation is quite an important topic for the aviation industry, obviously, and also for many other industries. So I thought we'll take a look at what CEPT is doing in this particular case on one of the spectrum regulation topics that are quite prominent these days and have come up a few years ago, first in the US, but then also in Europe. The compatibility between mobile networks, 5G networks in particular, and radio altimeters, since they're sitting in frequency bands that are closely adjacent, so operating next to each other. CEPT is working on that, looking at this situation to see if there's an issue. We've seen a lot in the media coming up a few years ago, firstly in the US and then in Europe, and so CEPT really wanted to take a look and see what the situation is. Is there really an issue, and how do we best address it? But the first question is, what is CEPT, to Mark's point? That is an association or organization of the 46 European telecommunications and postal regulators. So it's essentially the governments of 46 European countries, all the 27 EU member states, plus many countries around that. So larger European footprint, and the relevant entity in each country. It can be the telecoms ministry or the economics ministry, the spectrum regulator in those countries. And they are working together on spectrum regulatory topics. First of all, to look at the sharing coexistence situation for many different radio applications. Radio altimeters and 5G is only one of the many. There are many different radio applications, and they're all sort of competing for spectrum in front of the regulators, and so the regulators really need to make sure that the usage is efficient and does not affect each other. So it needs to coexist, but also be efficient usage and balanced usage, not just one industry getting everything, but needs to be balanced. So a lot of work is going on in these administrations, in CPT, with the various industry stakeholders, and that's really important for them to have involvement from the industries, because it doesn't really help much if the regulator is just developing all this in isolation and then it really doesn't work in practice. So there's a lot of engagement of the industries in these technical activities, and that in the end leads to a harmonized spectrum regulation for Europe, where then CEPT and also the European Commission in tandem are putting out harmonized regulation that is then implemented in the member states. So for radio altimeters and 5G networks or mobile networks, what are we looking at? First at the top, and I'm going to talk a bit about this, it's a bit of a busy slide. We have the situation, which is a bit different than the US. In the spectrum domain, we first have the blue box, which is the lower part of the 3.5 gigahertz spectrum, where we have the primary 5G deployments. Those have been licensed a few years ago in Europe. That was the primary 5G pioneer band. The European Commission pushed that a lot, and all the countries have licensed the 5G networks in that spectrum range. And so that is up and running. And then also there is another piece of spectrum just above that, the orange box, where we're now looking at possibly opening that up for low and medium power connectivity, more localized, some say industrial or vertical connectivity. If you have an industry campus, local area, or maybe a port authority that wants to do their own local connectivity network, that's the spectrum they're looking at. And then right above that spectrum sits the radio altimeter band, the green box. And so the closer we're getting to the radio altimeter band, the more we need to make sure that it doesn't interfere each other. The studies that we've initiated started a couple of years ago. There was a lot of, I shouldn't say noise, but there was a lot of news coming across the Atlantic Ocean from the US about altimeters possibly being interfered by the 5G rollout in the US, and work of the FAA and the FCC about some transitional measures and retrofits. And that was also brought into the European discussions with European governments, and Eurocontrol brought it up, a few countries brought it up in CPT and said, let's take a look at this and see what the problem really is. It is a slightly different situation in Europe compared to the US, so it's not just taking the US conclusions and applying them in Europe. We need to take a look ourselves. And given the experience from the past, we said we also need to make sure that we're working together on this, because what we've seen in the past is one industry has been working on this in isolation and said we need this, and then the other industry did something similar but came out with a different conclusion, and then they were just arguing in front of the regulators what they wanted and who was right and who was wrong. That was not seen productive, and it was really more a working together approach that the administrations in CPT wanted. So they got together with the aviation industry folks, with the mobile telecom folks, and sat down and started to study this issue. That's quite important, because when you design any kind of radio application, of course, you need to be aware of your environment and what is around you and what other systems are around you that are operating, and you might need to be aware of when designing the robustness of your system, for example. A couple of years ago, I don't know, some might still remember, in the US, we had the case of GPS and Light Squared, where the FCC wanted to introduce a new satellite system, a satellite terrestrial connectivity system, Light Squared, which was sitting in the spectrum just next to the GPS band. And the GPS receivers had been designed many, many, many years ago without even realizing that there could be other spectrum users sitting in bands just above or below them. So these GPS receivers didn't have any robustness against that system, and in the end, that new system could not be introduced because the GPS system would have been affected. So quite critical to be aware of the environment around you when designing systems, both for 5G but also for the altimeters. And that's why working together and exchanging the technical information is so critical. Another reason for working together is we need realistic assumptions. What we've had in the past was sometimes studies where people said, well, if I assume that the radio altimeter antenna is on the roof of the airplane, there is no problem. Well, that's fine, but that's not a realistic deployment because the antenna is at the bottom of the airplane. Likewise, others came and said, hey, I've found a problem if 5G is deployed near airports. If you put a 5G cell tower on the runway, it will interfere the altimeters on the planes. Like, yes, but we're not going to put 5G towers on the runway. So we need realistic assumptions to have reasonable study outcome and then decide on the measures that might be necessary once we know the magnitude of the problem. And that was a common theme that we've heard many times from governments in this process. They want to understand the magnitude of the problem, like how big is the problem? And that means we need to study various altimeter models. We cannot just, for example, study the worst performing altimeter on the market. That doesn't tell us how big the problem is. We need to look at different models, and that's what is being done right now. Based on all of that, the European governments would then decide, and that is in close cooperation with the European Commission and EASA, possible measures that might be needed. We've seen that, for example, France has taken a precautionary approach and has suspended rollout of 5G base stations in this frequency band very close to airport areas. So there's some restrictions on the operators where they can build out. Others have not done that and have said that there is no evidence yet that we need to do that. But that's really what we need to do to then come to the most efficient solution ensuring coexistence. So what we found so far is the 5G deployment parameters that we will see coming into these bands are already deployed in these bands. We've put them together and provided them to EUROCAE and RTCA in the work that Mark was referring to, the development of the MOPS for the future RA. Taking into account how the 5G deployments are looking like is quite important so that the MOPS can be designed accordingly to be robust against those systems. But it's not just about altimeters, it's more generally, it is important to know if in that altimeter band, in that green box, you're running other systems, like in the future, WAKE, wireless intra-aircraft communications, is another system being developed that should be running in this altimeter band. It is important when you design that radio application that you are aware of the other radio systems sitting around you to make sure the system works as intended. So that's something that was provided from one industry to the other to make sure that they talk to each other and they are aware of how they're using their systems. What we found so far for the upper part of the band, for the orange box, the studies have already concluded and we didn't find any issues based on all the assumptions that the industries agreed, as long as you have the base station outside of the obstacle-free zone. As I said, if you put a 5G cell tower onto the runway, there might be a different situation, but that's not a realistic study. The lower part, the blue box, that is still being finalized right now. And speaking of working together, as we speak here, the aviation experts and the telecoms experts from the base station vendors like Ericsson, Nokia, and so on, are sitting together in Paris, hosted by the ANFR, the French spectrum regulator, yesterday, today, having a meeting of the experts working through the technical details. We'll have another meeting of the full group that I chair in CPT in about a month from now to further progress that. And then by the end of the year, we'll have that work finalized, and that will then be the basis to determine how big is the problem, if there is one, and what is the most effective measures on both sides, not just on one side, what's the most effective measures to make sure there's a safe operation of those systems. What we've also done, some administrations at least, as part of this process, is they were quite active in saying, let's not just do simulations and calculations, let's do some measurements. How does it look in reality? So the French and the Norwegian administrations were very active in doing these test measurement campaigns last year and the year before. just to give us some additional data points to see how that possible interference would look like. You can see a list of helicopters and airplanes that they have tested. They didn't find any issues. They tried really hard, as you can see from the flight path and the pictures there. They did put a base station on the runway, well, on the tarmac there, and flew around with a helicopter, much closer than you would ever get to a 5G base station with a regular airplane on your approach slope. But they were trying to fly really close and around in circles as much as they could to try and see an impact on the altimeter, and they failed. They didn't see any impact. They couldn't trigger any malfunctioning of the altimeters. But that's just specific measurement setups and data points, just to complement the overall technical analysis. Now, what's next? The CPT work, as I said, will finish by the end of the year. And that will then be the basis for what the European Commission has just started to announce and sort of show around. It's still a living document, but the intention of the European Commission is to develop a EU roadmap to ensure the safe coexistence or operation, whatever the text is, between mobile networks and radio altimeters. So again, working together is the main theme. This is an activity from the European Commission, DG Move and DG Connect jointly, so the two DGs in the European Commission that are responsible for aviation and telecoms, working together on this roadmap. It's still work in progress. They're still developing it further, but I've put a few main points here on this slide that I've picked up from the latest draft that is circulating now. Obviously, they want to take a look at the CPT study results first and see where is the problem and how much of a problem is it in which case. And then the deployments of the networks, of course, would be done in line with the study results. So if, for example, around airports, we need to have a certain power limitation on the 5G base station to make sure that the study results are reflected, then, of course, that would be something that the telecoms regulator would implement in the licensing. If we see that a particular altimeter model is less robust against these signals than others, maybe for that particular model there is some discussion then on a retrofitting, like we've seen in the US. But those are all measures that they will look at and develop based on the study results. And that's why it's so important to study a variety of models and not just the worst performing one. With the information on the 5G deployment that goes into the MOPS development, and the MOPS being completed, then I think 2025 is the plan. We will likely see an update of the CPT studies with the new MOPS, factoring that into the studies and updating the studies, and we might then see some adjustment on the regulatory conclusions. Maybe some of the temporary measures would be lifted, maybe some retrofitting would go on, but those are the elements that the Commission is currently thinking through and talking to many administrations about what they see as a next step. What we need for that, and we are already doing it with many of these institutions that you see there on the right-hand side of the slide, we need involvement, continued involvement from all these different players. We need the regulators for that. We need standards organizations like EUROCAE. We need the RTCA. We need GSMA, GSA, more the telecoms manufacturer and operator side. We need Eurocontrol. We obviously need EASA to drive this, and the colleagues from EASA have been very active in trying to drive this and trying to bring industries together to talk to each other. So many people will need to be involved and are already involved in this, and then will hopefully fulfill that roadmap to ensure the safe operation and coexistence between those two critical systems. And I think that's all I have. Thank you.
So thank you, Michael, for the non-aviation perspective and informing on the work of CEPT. As a reminder, it's Working Group 119 is joint with RTCA 239. They're working on a MOPS for the next generation of radar altimeters. The generation, they're moving from a minimum performance standard, which is one single intended function, to a full MOPS, which is the whole system. So they've got the work cut out. There's been strong commitment from industry to develop this next generation MOPS, and the idea is to have a robust long-term solution for our spectrum compatibility of future radar altimeter equipment. So I think it's a very, very good speech, very good talk, and it shows collaboration between our industries. Thank you. So now we've finished the morning session, we can all go up one floor to get some lunch. I'm sure that you're all very hungry, so